So we are going to see resistance welding. So before that, we recap the previous lecture. In previous lecture, we have seen two joining processes, which are permanent joining process, in which first one is the arc welding and second one is the this one is the manual metal arc welding, which is a very useful welding method, and we can use it for very strong joints. This one is the transformer, and from that we pass current to this electrode holder to that electrode, and the electrodes or that molecules of that current flow is flowing towards the workpiece, and here, due to the gap between 2 to 3 millimeter, due to the kinetic energy of that flowing electrons bombarding on that workpiece and heat generates. Due to that, what happened? Due to that heat, portion of that workpiece and the electrode gets melted, and we get joint here. Okay. That electrodes are shown here. So this is the molten metal which is deposited into the melted workpiece. Okay. This is the manual metal arc welding. Now gas welding. Gas welding. This is the image of the gas welding, where these two cylinders are filled with the gases, out of which first one, that is black color cylinder, filled with the which gas filled in the black color? Yes.
Oxygen.
Yeah. Oxygen filled into the black colored cylinder, and acetylene is filled in this red color cylinder. So two hose means cable or wire, pipes are connected to these two cylinders, and they combine in the torch. So in mixing chamber, we get mixture of oxygen and acetylene. Then we get with the help of lighter, we can ignite this gas, and by adjusting the flow of oxygen and acetylene, we can create the flame, and this flame is used to heat the workpiece as well as the filler metal. Okay, by using that, we can joint sheet metals or some light parts. Okay, so these are the, so you can observe here, these are the gas welding and arc welding. Have you written this? Hello?
No, sir.
No, sir.
Okay. So this is the gas welding and the arc welding, difference between gas welding and arc welding. So heavy sections cannot be joined economically. So for example, if suppose one structure, some such structures are there which works under the heavy load. Okay. At that time, we cannot use this gas welding. For example, ट्रकचा पाटा बघितला तुम्ही? पाटा म्हणजे स्प्रिंग टाइप असतो, बघितला तुम्ही?
Yes, sir.
Yes, sir.
If we want to join this brake spring, lip spring, मराठीमध्ये पाटा म्हणतो, इंग्लिशमध्ये lip spring म्हणतो आपण. If we want to join this spring, lip spring, then we have to go for arc welding. And if suppose there is a breakage in the silencer of motorcycle, have you seen silencer?
Yes, sir.
Okay.
Sir.
So
Yes, sir.
to make joint in the silencer, we need that gas welding. Okay. Now flame temperature is less than the temperature of arc. So here we got near about 3300 degrees Celsius temperature, and in arc welding we got 4000 degrees Celsius. Refractory metals cannot be gas welded. Okay, arc welding can be employed for these metals also. Okay, refractory म्हणजे ज्याच्यावरून आपण रिफ्रॅक्शन होतो थोडक्यात, ज्याची नाव ते बघा काहीतरी माझ्या लक्षात येणार झिर्कोनियम इथं कुठे आहे बघा. So here limitations, actually it is provided like zirconium. Okay, so such refractory metals are there that cannot be joined with that gas welding. Okay, then gas flame takes a longer time to heat up the metal than the arc. गॅस वेल्डिंग जे आहे त्याच्यामध्ये लागणारा जो वेळ आहे, मेटल जे मेल्ट करण्यासाठी लागणारा वेळ आहे, तो आर्क वेल्डिंगच्या प्रपोर्शन मध्ये खूप जास्त वेळ लागतो. ते जर आपण आर्क वेल्डिंग मध्ये बघितलं की तो जो इलेक्ट्रोड आहे तो आपण तिथं टच केला की लगेचच तिथं मेल्टिंग चालू होते. ओके, कारण त्याच्यामधून फ्लो होणारे जे इलेक्ट्रॉन्स आहे, जे इलेक्ट्रॉन्स फ्लो होतात त्याचं स्पीड किंवा कायनेटिक एनर्जी एवढे जास्त आहे की आपण त्याच्यामध्ये गॅप थोडासा ठेवला की ते इलेक्ट्रॉन्स एवढ्या फ्लोने त्याच्यावरती बंबार्ड होतात की तिथे हीट जनरेट होते. ओके, तिथे काय होते, हीट जनरेट होते. ही एवढी फास्ट प्रोसेस होते. तुम्ही जर बघितलं, इफ यू चेक देअर at the time of joining with the arc welding, they required some gap in between the workpiece and the electrode. Electrode आणि workpiece मध्ये थोडासा गॅप ठेवावा लागतो. Okay, it is for that bombarding of electrons. For that skill the person is required, how much gap we have to keep there, how to maintain that gap. If you keep more gap than this near about 3 millimeter, then it will not work, it will not melt the metal. Okay, so flux shielding in gas welding is not so effective. Flux shielding, it means whatever coating is there in arc welding. Okay, arc welding मध्ये इलेक्ट्रोडच्या वरती जे फ्लक्स आहे, ओके, ते फ्लक्सचं काय काम असतं? who will tell me what is the function of that flux in arc welding? Hello, who will tell me that flux, what is the function of that flux? Okay, no one is.
स्लॅग तयार करतात सर तिथं.
Ha, correct, very good. So flux creates slag on the weld or that molten metal, and that flux also avoid contact of oxygen and nitrogen, which creates pores inside the joint. Okay, so that flux is effective in the arc weld. Okay, now here prolonged heating of a joint in a gas welding results in a larger heat affected zone. Okay, if you see in the gas welding, the surrounding area of that welding also get heated, and some that area is get black. Have you seen that? त्या शेजारचा एरिया पण असा ब्लॅक काळा पडलेला असतो गॅस वेल्डिंग मध्ये. Yes, have you seen that?
Yes, sir.
Okay, I think only Gurav is learning all these things. All others are only to listen, or I don't know whether they're listening or not. Let it be. So I got very poor response from your division nowadays. So where we are? So it affects large zone. In gas welding, it affects large zone where we do not require that much of heating. So in arc welding, it is not happening. In arc welding, what happens? It cover less area, okay, to heat and mold the workpiece where we require. Okay, so this is the benefit of this. Now next one is the spot welding. Now see, spot these two weldings, that is the arc welding and the gas welding, these two comes under the fusion welding. It means it melts the workpiece as well as electrode. Electrode means electrode is the filler metal, okay, which we are adding into the base metal. Base metal means workpiece metal. Similarly, in gas welding also we require filler metal. Okay. Now resistance welding is the different type of welding as compared to the arc welding and the gas welding. It comes under the plastic or pressure weld. Okay. So we have seen that in types. See here, arc welding, gas welding, after that resistance welding. Resistance welding is mostly used for sheet metals. Okay, in this we are passing the currents through the electrodes, and when we pass the current through the electrodes, we keep plates or the sheet metals where we want joint, we keep that plate in between these two electrodes. So what will happen? It will create resistance. It will, that sheet metal create resistance to the flow of current, and due to that heat produces at that point. At that point heat produces, and that heat convert that metal into the plastic mold, and with the help of a paddle we add some load or pressure on that point with the help of electrodes, and we get joint. So we have image for that. I will show you image because you have not seen this machine. I know that. So have you seen such type of machines?
No, sir.
No, I know that. Because it is not working in our day-to-day life. You see here, this is the transformer, or we can say a capacitor, which controls the flow of current. Here we have one arm, and to that arm electrode is fitted. This one is the copper electrode which is fitted on the arm or the upper arm. Another arm is here, that is the lower arm, we can say lower arm, and this one is another electrode fitted in that arm. Okay. Here this upper arm is movable. Get it? This arm can move in downward direction as well as in upward direction, and this lower arm and this electrode are stationary. Okay. Here this paddle is given. This paddle is given to apply the force. When we apply force here with the help of foot, so what will happen? This electrode move in the downward direction. This electrode move in the downward direction, and it touches to this lower electrode. And when this touches to this lower electrode, current will flow. Current will flow from this upper arm to the upper electrode, and from upper electrode to lower electrode, and to again to the transformer. Okay, this is one circuit. This is one circuit. So if there is no change in material, that is copper. Copper is a very good conductor of electricity. Correct? After copper, there is aluminum and another materials are there. But the copper is very, very good conductor of electricity. So that transformer work as instant, we require instant current here. So the transformer again having one more circuit to supply the current. It is work like capacitor. Okay. So when current flowing here, if I put sheet in between them, sheet it means patra suppose. So आपण पत्रा वापरतो. This welding process can be used for near about 3 mm thickness, for 3 mm thickness. Now see, if I want joint here, if I want joint here, so I will press on this paddle. I will press on this paddle. When I press on this paddle, what will happen? This electrode move in the downward direction, also current flow through that electrode. And as I put workpiece in between these two electrodes, there is resistance. Okay. Resistance means the flow la resistance create with the current. And due to that, here heat is generated. At this point, heat will generate. Okay. And due to that heat, this sheet metal, due to that heat, that sheet metal is converted into the plastic mold. And due to that pressure we applied with the foot, it will get connected or combined. Here, we do not require any another filler metal. What do we simply do? We simply convert that sheet metal or that point into the plastic mold, and then we apply the pressure. Okay. For example, एखादी प्लास्टिकचा कागद किंवा प्लास्टिकची बॉटल आपण थोडा वेळ जर हीट वरती पकडली तर कशी होते, ती लूज पडते. बरोबर आहे? ऑब्झर्व केले कधी?
Yes, sir.
Yes,
Yes,
sir.
sir.
ती अशा प्रकारे ज्या वेळेला थोडीशी लूज पडते त्याच्या सर्टन टेम्परेचर पर्यंत, आणि त्यावेळेला जर ती आपण दाबली, अशी प्रेस केली, तर दोन प्लेट्स एकमेकाला जोडू शकतात. ओके. मग अशा पद्धतीने ती पूर्णपणे मेल्ट पण झालेली नाही. ओके. ती पूर्णपणे मेल्ट पण झालेली नसते. मग आपण त्या ठिकाणी जर प्रेशर अप्लाय केला तर एकमेकाला काय होतो, जॉईंट होऊन बसू शकतो. मग तीच प्रोसेस इथं आहे, फक्त इथं करंटच्या माध्यमातून केलेली आहे. दिस process is very simple process. Very simple process. We can do automation in that process. But as compared to the arc welding and other gas weldings, here we have limitations. Near about 3 millimeter sheet metals can be joined here. If the sheet metals is bigger than this, we cannot do that operation. Okay. The joint is bigger as compared to other joints or other joining processes. This joint is weaker. Now we have, this one is the machine actually, so we can't draw this diagram. We will see another diagram for our drawing. Can you observe this? Hello, can you observe
Yes,
this
sir.
diagram?
Yes, sir.
Yes, sir.
Now, okay. So here is the welding power supply. That means transformer. It is shown with symbolic representation, and welding current flows through that arm to the electrode. Okay. And here we get one nugget. Nugget म्हणजे एक गाठ तयार होते छोटीशी. When we pass the current, it creates that workpiece creates resistance to flow of current, and due to that, this workpiece converted into the plastic mold. And if we apply the pressure, that plastic or that point is joined together. Okay. Here, this one is the spot welding. Okay. We have only spot welding in our syllabus. One more process is also in that resistance welding, that is the seam welding. In seam welding, two rollers are used where the continuous point welding or continuous continuous spot welding can be done. Okay, that we will see in the video. So up to that, is anyone having any doubt here? See how much current flows from this wire. It is depend, the transformer can change this current as per the requirement with that workpiece. Okay, if it is if the workpiece is of copper again, so it will create less resistance. If it is of mild steel, it will create more resistance. Okay, so anyone having any doubt in this? Yes or no?
No, sir.
No, sir.
No, sir.
Okay, before drawing this diagram, we will see videos on that uh, spot welding or the resistance welding, and then we will proceed for the diagram. Are you able to see this?
Yes,
Yes,
sir.
sir.
Yes, sir.
Resistance welding. Resistance is the
Can
property
you
of the
hear
conductor
audio
by
of
the
this
virtue of which it
video?
resists the flow of electrons.
Yes, sir.
Flow of current
Yes,
Yes,
sir.
sir.
Yes, sir.
resistance to the flow of electrons creates friction and heat. This heat generated is then used to join the two similar or dissimilar metals by melting and forming a bond between them. Types of resistance welding processes. 1. Spot welding. 2. Seam welding. Spot welding. Spot welding is also known as the resistance spot welding process. It is used to weld thin sheets of metal together by applying pressure. The heat required for welding is generated by resistance to the flow of current through the electrode. Working principle. The welding electrodes are made up of copper, which is a good conductor of electricity. The movable and fixed electrodes of the spot welding machine are held in pressure on either side of a pair of plates to be welded together. As the current passes, it experiences the resistance between the electrode and workpiece contact and generates heat. This heat causes the interface of the workpiece in contact with another workpiece to melt, and pressure fuses the two metals, thus forming a solid bond. If you are enjoying this video, please give this video a thumbs up, and if you are new to ADTW Learn, click on the subscribe button and turn on the notification to get more informative videos like this. Equipment required. Spot welding machine. Tongs, also known as electrodes. Working of spot welding. When the power is turned on, the transformer supplies the low voltage high current to the electrodes made up of copper. These electrodes are held in pressure against the pair of workpieces to be spot welded with the help of tongs. The current flows from the tongs to the electrodes, as copper is the good conductor of electricity but faces resistance at the point of contact between the two workpieces. This resistance generates the heat at metal-to-metal interface and causes the two metals in contact to melt. Then the pressure causes the molten metal to fuse together, and thus a solid bond is formed. Application of spot welding. Spot welding is used for welding thin sheets together. In the manufacturing of fuel tanks, joining vehicle body parts, radiators, wire ends, etc. Advantages of spot welding. The process can be automated. The process is simpler. No filler metal is required. Low or no fumes is generated. The high welding rate is possible. Limitations of the spot welding process. The initial cost is high. Low strength due to discontinuous weld. The process is limited to the thickness of the metal. Seam welding. In seam
Now
welding,
this one is
the
another
workpiece
type
is
of
supported on both
resistance
sides by a
welding.
pair of electrodes. These electrodes are in the form of rollers to produce a continuous weld on the workpiece. Continuous spot welding is known as seam welding. The working principle of seam welding is similar to that of resistance spot welding. Equipment are components used in the process. Seam welding machine and roller electrodes. Working of seam welding. When the power is turned on, the transformer supplies the low voltage high current to the roller electrodes. Made up of conductive materials. These roller electrodes support the pair of workpieces to be welded together. When the rollers are made to contact the workpiece, the current flows easily through the roller electrodes with a low resistance, but experiences a high resistance at the metal-to-metal interface, that is between the upper plate and lower plate to be joined. Thus high resistance to the flow of current, offered by the pair of workpiece, raises the temperature to the fusion point between the workpiece interface, and a weld is generated in the form of a nugget. Nugget is a weld between the two workpiece interfaces. Application of seam welding process. Welding of transformer, paint containers. Welding of gasoline tanks. Automobile mufflers. Welding of sheet metal tanks. Advantages of seam welding. It can generate a leak-proof weld. The production rate is high. Dissimilar metals can be welded together. No filler metal or flux is needed. The processes can be automatic or semi-automatic. It is possible to weld thin metal sheets with this process. A semi-skilled person can also produce a good weld. Limitations of seam welding. The welding process is suitable for thin sheets only up to a thickness of 3 mm. Since the electrodes are in the form of rollers, they can weld only along a straight line or well-curved path. The process is limited to the lap joints. I hope you have understood resistance welding and its types.
Have you understood?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, now we will see if suppose some welding processes, actual how it works. So this one is the animation that we've seen. Now we will see actually how it works in machine shops. This one is very good or a simple process. Once you observe it, you can also perform this resistance welding. See, this one is the resistance welding. Simple. This one is very fast process of joining and very advanced process. Here we do not require any filler meter. In all other processes, filler metals are required. Okay, so this one is related to resistance welding. You understood?
Yes, sir.
Yes, sir.
Okay, now you can draw diagram. So draw this diagram. This diagram can be understood easily. So this part is very important. That is electrode, that nugget joint, temperature. After completion of this diagram, please tell me. Is this visible clearly?
Yes, sir.
Hello, over.
Yes, sir.
Yes, sir.
Yes, sir.
So here, here are the advantages and disadvantages of the spot welding. So what are the advantages? That no filler metal required. So in spot welding, we do not require any additional filler metal. Uh, as we have seen in the arc welding, in the gas welding, we need some extra filler metal. Metal, it means metal other than the workpiece. Okay, that metal also melted, and we deposit that melted metal in the that molten workpiece. Okay, understood? समजलं तुम्हाला मी काय म्हणतोय ते?
Yes, sir.
आपण याच्या अगोदरचे जे वेल्डिंग प्रोसेस
Yes.
बघितल्या होत्या त्याच्यामध्ये इलेक्ट्रॉड यूज केला होता किंवा एक फिलर मेटल यूज केलं होतं जे आपण मेल्ट केलं आणि ते मेल्ट केलेलं जे फिलर मेटल आहे ते मोल्टन केलेलं किंवा मेल्ट केलेलं अगोदरचं जे वितळवलेलं वर्कपीसचा जो भाग आहे त्याच्यामध्ये ते आपण ऍड करत गेलो कशासाठी स्ट्रॉंग जॉईंट होण्यासाठी ओके आणि ते परत कूल करायचं if we compare this spot welding with that arc welding and the gas welding, here we do not require any filler metal. Okay, high production rates possible. If you see that welding or the spot, it required less than 2 seconds or 3 seconds. Okay, it required very less time as compared to the arc welding and that gas welding. Lends itself to mechanization and atomization. Actually, it is leads to we can do automation. If, for example, we have to join sheet metal and we require to spot weld at certain point, so we can atomize. We can do atomization in that machine or in that process also. But for arc welding, it is not possible. It required to operate manually. Okay, lower operator skill level than for arc welding. Here required very less skilled person. If suppose you observe it and 1 or 2 times somebody tell you how to perform this operation of resistance welding, you can do this operation very easily. Okay, good repeatability and reliability. It means it is not required that much time. If I do one spot welding or one spot, and after that if I have to do another spot, it does not require that much of time which is required in the arc welding. Okay, so in arc welding, in gas welding, there is required a lot of time to ignite that flame, to start the oxygen, to start to acetylene, then control that flow, and then we are starting to join the metals. Okay, that things are not required here. So these are the advantages of spot welding. Now disadvantages: high initial equipment cost. This spot welding machine having large price as compared to the arc welding and gas welding. Gas welding is the very cheap joining process. Then limited to lap joints. We cannot join, as I have told, if we have to join the lip spring of the truck or buses, then we cannot use this spot welding. For only sheet metal work, we can use this sheet metal work or some small rods that we have seen in the video. For that purpose, we can use this spot weld. Okay. Sir, still diagram not complete. Okay, Sakshi. So in that advantages and disadvantages, have you seen that advantages and disadvantages? So some students
sir.
are lagging in drawing the diagram. So once again, I will show this diagram, or I have erased it.
तर मग कशी वेगळं स्लाइड दिसत होते डायग्राम तुम्ही सर्च करत होता ते दिसत होतं.
होय का?
हा, yes, sir.
Yes, sir.
मी त्या स्लाइड ज्या आहेत ना त्याच्यामध्ये नव्हत्या म्हणून मी ऍडव्हान्टेजेस आणि डिसएडव्हान्टेजेस घेतले. One second, I will show you once again. Is that visible now?
Yes, sir.
Yes, sir.
Okay, so the students who are remaining to draw this diagram, drawing this diagram, please draw it. Actually, point from that spot welding was removed. After completion of this diagram, please let me know. Then you have to write these advantages and disadvantages.
Complete, sir.
झाली? सगळ्यांची झाली?
Yes, sir.
Yes, sir.
Now write these advantages and disadvantages. So this joining process is very simple for light joints. And the skill required is how much time we need to do one joint. If you keep it as it is for long time, it will create hole. If thin sheet metal is there and if you are going to do that joint and if you press it for long time, then it will create hole. So for that, it is necessary to understand how much time required to complete this joint. With this, we will take attendance. Attendance open. So today is the 3rd of February 2022. So I think 2 points remaining, that is soldering and brazing from this chapter. So we'll complete these 2 points in next lecture. And for ISE 1, these 2 chapters are for syllabus, as a syllabus. Okay. Have you understood
Yes, sir.
Yes.
what I said? What I told now
About ISC exam.
about ISE exam,
2 chapters will be there.
2 chapters will be there. Very good. So all others, please listen. For ISE 1, 2 chapters will be there, and these 2 chapters are first one, that is the pump, compressor, turbine, and second one is the machine tool and joining processes. In ISE also 15 question, actually 30 marks ISE will be conducted. And in that 15 questions will be on basic civil engineering and 15 questions will be on basic mechanical engineering. Get it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Is anyone having any doubt about this?
No, sir.
No, sir.
So give attendance. Roll number 1,
Present, sir.
2,
Yes, sir.
3, 3. Deepali Chaudhary. Okay. 4. 5.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7.
Present, sir.
8.
Present, sir.
9.
Present, sir.
10.
Yes, sir.
11.
Present, sir.
12. Roll number 12 absent. 13.
Present, sir.
14.
Yes, sir.
15. Roll number 15 absent. 16.
Present, sir.
17.
Yes, sir.
18.
Yes, sir.
19.
Present.
20.
Present, sir.
21.
Present, sir.
22.
Present, sir.
23.
Present, sir.
24.
Present, sir.
25.
Present, sir.
26. Roll number 26 absent. 27. 27 absent. 28.
Present, sir.
29. 29 absent. 30.
Present, sir.
31.
Present, sir.
32.
Present, sir.
33.
Present, sir.
34.
Yes, sir.
35.
Present, sir.
36.
Present, sir.
37. 37. 38.
Present, sir.
39.
Present, sir.
40.
Present, sir.
41. 41. 42.
Present, sir.
43.
Present, sir.
44.
Present, sir.
45.
Present, sir.
46.
Present, sir.
47. 47. Aishwarya.
Yes, sir.
No, not 57. 47. Absent.
Yes, sir.
48. 48.
Present, sir.
49.
Present, sir.
50.
Yes, sir.
51. Utkarsha Shinde. 51. 52. 52. 52 आहे का? 52. Anisha absent. 53. 53. Avinash Nanavre absent. 54. 54. Narhe. Okay, 54 is present. 55. 55. 55. Absent. Okay, 55 is present. Okay, 56.
Present, sir.
57.
Present, sir.
58.
Present, sir.
59. 59.
Present, sir.
60. Okay.
Present, sir.
61. 62. 62. Furat. 62 absent. So I have to check.
Present, sir.
25 is present, 37 present, 54 present, 41 present. So the absent roll number 12, 15, 26, 27, 29, 51, 52, and 53. These are the absent roll numbers.
Sir, 51.
Okay, 51 Utkarsha Shinde. Okay. With this, we will stop here. We will meet tomorrow in next lecture, and we will see soldering and working of soldering and working of brazing. Okay. So thank you all of you.